Hey everyone, welcome back to The Explainer. So, when you hear the word chemistry, you probably picture, I don't know, massive labs, scientists in white coats, safety goggles, the whole shebang. But actually, chemistry is happening right in front of you, literally right now, inside your home and even inside your body. Today, we're focusing on an absolutely fundamental concept, the pH scale, and why it is incredibly important in our daily lives.
Okay, let's dive right into this with a quick mental experiment. Imagine I place three identical glasses right on the table in front of you. Glass 1 has lemon juice, glass 2 is just pure water, and glass 3 contains a soap solution. Now, if you're just looking at them, they look almost identical, right? They're completely colorless, perfectly transparent. At first glance, you might think they're basically the same liquid.
But, as you've probably guessed, the chemical reality is a whole different story. What our eyes see isn't the full picture. That lemon juice is acidic, the pure water is neutral, and that soap solution, it's completely basic. Honestly, there is absolutely no way you could tell them apart just by looking.
Section 1, why do we need pH?
Imagine you're a scientist who needs to accurately compare these substances. If you just use words like, oh, this one's acidic, or that one's basic, well, that's incredibly vague, isn't it? It's kind of like a teacher grading an exam paper. If they just wrote good, average, or excellent on your test, would you really know exactly how well you did? Definitely not. You need exact marks, right? Like a 95, an 80, or a 60. Numbers just give us a crystal clear, unmistakable picture. And scientists? They wanted that exact same level of precision for acids and bases. They desperately needed a numerical scale.
Section 2, decoding the pH scale.
That need for absolute precision led to a brilliant solution, the pH scale. Now, the term pH actually stands for potential of hydrogen. To really get why this works, we have to remember a golden rule of chemistry. Acids release hydrogen ions when they dissolve in water, like hydrochloric acid, for instance. The more of those hydrogen ions floating around in a solution, the stronger the acidic nature is. Scientists realized they could literally just measure that exact concentration of hydrogen ions to figure out the acidity. So, in simple words, pH is just a numerical value that tells us exactly how acidic or how basic a solution really is.
The entire pH scale ranges from 0 all the way to 14. But I want to draw your attention right to the dead center of this scale for a second, the number 7. A solution with a pH of exactly 7 is called neutral. It is perfectly balanced. Pure water is pretty much the absolute best example of this. It's not acidic, it's not basic, it just sits safely and exactly in the middle. Let's see how this builds as we move away from the center, starting on the left side of the scale. As we slide down from a neutral 7 towards 0, the acidity ramps up. So a pH of 6 is acidic, but a pH of 5 is more acidic. Hit 4 and it's even stronger. By the time you drop down to a pH of 1, wow, you are dealing with something extremely acidic. So the lower the number, the stronger the acid.
Now let's flip over to the right side of the scale. As we climb upward from neutral 7 toward 14, the basicity increases. A pH of 8 is basic, a pH of 10 is more basic. Hit 12 and it's strongly basic, and a pH of 14, that is extremely basic. So the higher the number goes above 7, the stronger the base becomes.
Section 3, a common misunderstanding. Before we go any further, I have to clear up a major trap that so many students fall into. A lot of people see a pH of 3 and a pH of 4 and think, they're right next to each other on the scale, the difference must be tiny. Actually, scratch that. It's not true at all. The pH scale is not an ordinary ruler. Each single step represents a massive change in acidity, meaning a solution with a pH of 3 is way more acidic than a solution with a pH of 4. This is exactly why scientists take these numbers so seriously. A seemingly small numerical shift indicates a massive chemical difference in the real world. Which brings us to Section 4, chemistry in everyday life.
Speaking of the real world, let's take this theoretical scale completely out of the laboratory, because without the pH scale, everyday professionals would seriously struggle to do their jobs. Think about it. When you visit a doctor, they check the pH of your blood, your stomach acidity. Literally measuring your health depends on it. Farmers test the pH of their soil to make sure their crops will actually survive. Massive industries use pH to manufacture the products we buy every day. Even the companies making your morning toothpaste have to perfectly balance the pH. Let's look at some super familiar household items to prove that chemistry is constantly working right under our noses. On the acidic side, the stuff with a low pH, we have things you probably eat or drink, like lemon juice, vinegar, curd, and tomato juice. In the neutral category, we have our pure water, perfectly balanced at 7. And on the basic side, we find our cleaning supplies, soap, detergent, and lime water. You are interacting with these substances almost every single day. So, the crucial point I want you to take away from this is that chemistry is definitely not confined to some distant laboratory. It is alive and active in your kitchen when you cook, it's in your bathroom when you use soap, it's in the soil in your garden, and amazingly, it is constantly working inside your own body, from the blood flowing through your veins to the acids breaking down your food. Seriously, pH affects almost every single aspect of human life.
To wrap up today's explainer, I want to leave you with a little challenge to test your new knowledge. Look around your house today. Can you identify just one acidic substance and one basic substance that you use all the time that we haven't already discussed? Drop your answers in the comments section below and let me know what you find. Thank you so much for joining me today. Keep learning, keep exploring, and keep asking questions. I'll see you in the next explainer, where we're going to dive into universal indicators and find out exactly how pH affects digestion, soil treatment, tooth decay, and, wait for it, bee stings. You definitely won't want to miss it. Happy learning.